Hello, everyone, and welcome to our podcast, Coffee and Tech, the podcast powered by our passion for electronics and coffee, of course. In today's session, we are going to talk about PCB design, PCB manufacturing. My name is Antonio Becerra, and today with us is Matthias Stickel from KSG. Welcome, Matthias.
Thanks for inviting me here.
It's a pleasure. KSG is a renowned PCB manufacturer, radicated here in Germany, and KSG is famously catering a wide array of different industries, from automotive, consumer electronics, industrial, and more than just doing PCB manufacturing. It's also more about pushing the boundaries of what can be done, offering cutting-edge processes for PCB, for both manufacturing, and all in all, understanding what are the customer needs so that value can be delivered. So that is why we wanted to have today the presence of Matthias today with us, because in the frame of PCB manufacturing, PCB design, we're going to be talking about design for manufacturing, design for manufacturability, in short, DFM, which is something very important to take into account as one matures as an engineer, right? So yeah, I think let's get started. And as most of our audience probably already know, and those that might have just joined the podcast, I will explain it. Here at Sillus, we have the Sillus Design Platform that it is a great solution to help electronic designers capture the system architecture and the technical requirements that they have, and out of that generate essentially a prototype that consists of schematics, BOM, and a very simple floor plan. But the key here is that after capturing your system architecture, what the platform does is offers the engineer solution. The engineer is indeed on the driving seat, which is very important. Right? As an engineer, we've been discussing some time ago, you need to be the owner of your work, of what you're doing. So it's for you to evaluate the solutions that the Sillus Design Platform is offering you. And among other things, key for evaluating which solutions to want to implement, DFM, right, and communication with the manufacturer is very important. Which it brings me to the question of, from your perspective, from KSG's perspective, what are the critical DFM principles that sometimes PCB designers tend to overlook, and how does this impact the overall manufacturing process?
Okay. Oh, that's a big one to start off with.
Yes, it is. We start strong.
Okay, so first of all, starting off with the stack up, the way the layers are put together over printed circuit board. So you have a combination of copper layers and isolational layers, and sometimes adding, depending on the way the copper layers are connected, sometimes adding 2 additional copper layers is not just 2 more copper layers. It means the sequential buildup, meaning you have to run through the entire processing multiple times, adding, of course, cost and lead time. So that's for sure one of the things you need to consider concerning the stack up generation. Next thing is basic things on how you connect the pads with traces, and which angle, if you do teardrops or not.
Mm-hmm.
Then there could be things like if you have impedance requirements, the way you do the routing, how you route differential pairs across the board, if they pass plane layers and so on. And there are for sure also things that might be trivial.
Mm-hmm.
Like sometimes for technical reasons, people want to have a different color of the solder mask. Solder mask is the green part.
Yes.
And for technical reasons, it could be, for example, for illumination, that you have LED applications. you want to request white solder mask, and people think that it actually saves money if they only put the white solder mask on one side.
Mm-hmm.
But it actually adds cost because you have to run through the processing twice.
Correct.
And things like, for example, also the surface finish, even as the connection to the components.
Mm-hmm.
It's a very critical element which can drive the cost in a large way up to 15-20%. And so you only need to focus on what you really need and not what you might be able to get, because there are things like cost, shelf life, high frequency applications, and things you need to consider. So there's many things that actually drive the design for manufacturing. Also, for example, tolerances. If you look in the typical standards, what copper weights, typically copper is measured in thickness, but it's actually offered in weight and area weight. And what you don't read about is the tolerances that are allowed for the copper thicknesses. So, for example, if you have an 18 micron, which would be half ounce, it could go after processing down to 11 micron. If you don't consider that in your simulations, then the whole thing won't work. So again, it's wide range where you can screw up things. So it's important to consider some of the things already in the early stages.
Absolutely. That is actually, I would say, one of the key things, right, of design for manufacturing. In a previous life, I supported many customers with an EDA that were starting to work with a specific EDA tool, and I would say for design for manufacturing, in the end, you can say it in a couple of sentences. Design for manufacturing is implementing processes while you are defining your PCB, right, your layout, or sometimes even selection of components, taking into account, having in mind always the manufacturability of your board, right? Because it might look in your head, it's an awesome board. You're gonna have, I don't know, multi-core or layers and whatnot. It's gonna cost a lot of money if you have a mixture of SMD and through-hole components, or right. If you need for whatever reason, different methods of soldering, right? Double-sided PCBs, different via sizes, and in the end, those are the things that one needs to take into account. And what we always told our customers: talk to your manufacturer, right? Best practice for design for manufacturing is be in contact with your manufacturers.
Just get engaged in the early stages, because it's something a crossing, and it's important that you don't go right, that you turn left.
Exactly. And something as simple as it can be. I mean, simple is easier said than done and changed. But it could happen to not so seasoned developers, not so seasoned engineers, that you pick a certain layout, a certain layer stack-up, and you have to do differential pairs, control impedance, routing, and whatnot. And then you send the board, or you talk with the manufacturer, and you need to change the layer stagger, right? So now you need to change it.
And sometimes it's even simpler than that, even with the base material selection. So the base material can also up to 32% of the cost.
Exactly.
And if you specify something which you don't really need, then this would not only have direct cost on the base material, but also, for example, if you look at the drilling process of a printed circuit board, typically you would stack printed circuit boards and drill multiple PCBs at the same time. And depending if you have heavily filled materials, you cannot do that, or the drill wear is so excessive that the drill life decreases in such an amount that it's just getting more and more expensive. If you don't need that, it's just a waste of money.
Yes, that's also very important. I was discussing some months ago with a colleague that from a former company that was asking me about some boards, and if I could take a look. Nothing proprietary, so nothing illegal. My friend wasn't breaking any law. But what I realized is that, so when I checked, there were like, if I remember, approximately 7 or 8 different via sizes. right? And it's like, do you really need those different VSIs?
Tolerances follow the time.
Right, exactly. Because every time you change the VSIs, it's a different process. It's gonna take longer. It's gonna cost you more, right? Or I don't know, things like it look cool. A PCB, maybe depending on what you're doing, with rounded edges and whatnot. Beautiful, but do you need that process? Because it adds cost to it, right? So that's always something to take into account. And in many occasions, I mean, for engineers that have a lot of experience, this tends to, they have learned sometimes the hard way. Most of the times, probably the hard way, right? But I think it's very important to take all these things into account, to learn and to read about DFM. And I would recommend anyone watching. There's tons of materials online. The IPC association also has tons of directives about
Webinars about it.
Exactly. KSG has webinars about it. Exactly. Very, very important. Very important. That's key. Actually, I would recommend everyone check the KSG webinars. I think I don't know if I've ever learned more about manufacturing for my job as a designer than watching webinars from a manufacturer, right? Because that's information that you need to know about how to do things and all the capabilities.
Oh.
That's key. And one of the keys, one of the reasons why we're talking about DFM is because taking into account DFM rules and talking to your manufacturer helps to streamline the design process, right? The PC manufacturing process. When you do things right, you don't need to do many respins and rework that cost time and money.
And sometimes it's just if you've experienced it. We talked about the stack ups early on.
Yes.
And for example, you can generate isolational layers with different prepregs. Different prepregs meaning the glass cloth has a different thickness. You add different missing contents. But after all, it's a manual process setting up the stack up. So if you add tons and different prepregs in different combinations, there's the poor guy standing there, like in a burger place. So he needs to assemble the printed circuit board and making sure he doesn't mix up anything. And so that's one of the things, just to keep it simple. And of course, if you need to match impedance requirements, you have to do so. But if we've seen stack ups where you have in between two couple layers, 4 different types of prepregs, which is just nonsense.
Yeah, that's probably not necessary, right? So in the end, it is about streamlining the PCB design process, right? The PCB manufacturing, and I think that's a very good common point, because in the end, in this session of the podcast, we're covering 2 sides of the design process. Sellers supports engineers and electronic developers on the prototype capturing, on the system architecture development, and taking into account the different requirements and providing, schematics, BOM, and then you hand over the project to the layout, to the EDA software, and there is where we start playing around. There is where now more conversation with the manufacturer. Although I would even say in early stages it's also important, but that for sure is something where you have to start doing it, right? And you start selecting, as you said, the layer stack. So since we're talking about streamlining the design, we streamline transforming system architecture and technical requirements into an actionable circuitry that the engineers can evaluate. Now, my question for you, because we're a new platform, right? Actually, for those that might not know, we launched the platform publicly in April. So it's for free for everyone to join. But now, enough with the ads. How does KSG collaborate with tools and platforms like ours, for example, or others, right? It's fine to ensure that DFM principles are effectively integrated into the design that you are receiving?
So to be honest, in the past, we were pretty hesitant because most of the platforms just focus on purchasing departments and cost efficiency, and not really on DFM things. So it's just what people are used to from their private life. So whatever platform they order something is transferred into the business world and spiced up with some technical ingredients. So everybody hosts with some key features or attributes. It's enough to get a decent, precise pricing. And this is where we sort of were a little reluctant, because that's not the type of business we focus on. But what we see also in parallel, that the expertise and the knowledge is shrinking. So people retire, and so it's just an efficient way to add common sense into some rules somewhere in the back. And this is why I think we're much more open now to consider things like that. Because again, you just you save time in the initial phase if you don't need to talk back and forth on things which used to be maybe common sense, but sort of got lost.
Might have gotten lost. Yes.
Yeah, and this is why I think for sure there's also a long way to go in terms of that we have our own tools on copper mapping, copper balancing, on the thermal simulations. And things that we need to consider before we go into production. But sometimes this also might have an influence on the design and the layup and the stack up. So again, I think for sort of commodity products, for sure, it's a good way to go. But to squeeze the limits, I think it's still good if there's an interaction discussion of the people's setting up this design, because also there might be board shop specific things that are relevant for that.
So absolutely, I recall. So indeed, I agree with you. Most of the solutions, streamline, evaluate your solutions to do some cost-effective optimization. To cost optimization is actually more focused on the component than on the board itself. From what I know, from what I've heard, right? The kind of the board and selection of materials and whatnot is almost like this is led to the expert, to the engineer, and that's indeed a very good point. And I've kept hearing over and over the problem that the experienced workforce is retiring now. Most of the electronic engineers go more to some software development than to hardware development, which means that in the end, the knowledge about the industry is shrinking, right? And that's that is, from our point of view, where platforms like the sales design platform can help, because they help implement rules. We don't do PCB. That's your half of the business. But that's important, right?
Yeah, so the thing is, since I'm responsible for the capabilities and the way we get there to achieve the capabilities, it's now not always black and white. So so with some minor tweaks, you can make something possible or enable something which was impossible before. But if you ask me for something just black and white, you're gonna have a black, and it could have gone white.
Of course,
with some minor adjustment.
Of course. I want to talk with you about challenges. We have on our half of the board, we have seen many challenges on finding the components that you need to solve your board. Essentially, when you get an assignment or you want to build up your own board, if right, with your spare time, or doesn't matter if it is for business or leisure, that you have an idea that transforms into a certain architecture, and now the designers need to go through tons of data sheets, reading to figure out which component do I need, or you go to a typical supplier website where you get a list of 300 components, and now what do? You pick the one from the top, you read 20 data sheets. That's very time consuming, right? And that is where we put a lot of value, because then you capture your system architecture and the requirements interfaces, functional specifications. You can capture many things, and then our platform gives you suggestions, not only the component, but also the implementation. So the application node that is then output in EDA format for the EDA tool. And that is one of the biggest challenges that we have identified and that we help solve on the schematic side, on the previous side of transforming the requirements into actionable circuitry. And I wanted to ask you, what are on the PCB manufacturing side some of the most common challenges that you find that people might struggle with, and essentially things that you communicate and that communicating to the customer about PCB manufacturing?
I mean, the thing that you mentioned, that you sort of generate building blocks to simplify life, is something that we also see, and we talked about layer stack ups earlier. And I think there's so many things. And in addition to the variety that you can screw up in a stack up, making life difficult. And this is why, for example, this is something where we see predefined stack up as a big benefit to make life easier. For example, in an convention. So one of the things that is a challenge downstream after the printed circuit boards in assembly is warpage, twist and bow.
Yes.
And there are some things that you just can consider in a stack up. Starting out very simple, that typically you count the number of copper layers, and if you have an even number of copper layers, and you make it symmetrical, meaning you have a center line and mirror everything around the center line, this is for sure one of the things that makes things easier. For sure, there's sometimes a trade-off in terms of cost. For example, for ADAS applications, automotive applications, typically you have high-frequency materials that you want to only spend where you need it. And this is why you start off with special stack-ups where you have one high-frequency core on the outside, and you make an uneven number of copper layers. And then there's a huge risk of getting the whole thing crooked and warped. And also because there's just it's just physics. I mean, you have in the lamination process, you have expansion of the different layers, and if there are different materials, or then they expand differently, and if they cool down, then they shrink
also different,
and then it starts to get crooked. So things like sticking to the stack ups, also mixing resin systems. So we've seen stack ups where you have different resin system. The resin is the more or less the glue in the printed circuit board, and we have so-called recipes. Meaning every epoxy resin system or non-epoxy resin system has its own lamination profile, being temperature, vacuum, and pressure. And once you're in the lamination press, the resin, which is initially a powder, gets lower in viscosity, gets towards honey or water. And then you add the lamination pressure, and every epoxy system has its own way of its own curve for the viscosity. And if you combine different resin systems, they're gonna differ.
Of course.
It's gonna change the behavior in a different way, and it's gonna get crooked. So these are very simple things, similar but much more simplified than your building blocks that you're doing. That you just sort of have a toolkit, and you can grab different stack ups for different constructions. But you already make sure that it keeps the efforts as low as possible.
Yeah, that is always. I think always having. I've always recommended having templates, right? When you can, in the end, have things that you don't need to rethink every time because they're proved. That's very important. You have solutions that you know that work on previous projects, and you want to recall it. Right, you just, if it is a layer stack, can have it as a template, paste it and go for it. That is super important. And I wanted to talk now a bit about trends in the industry. on our side of the field, on the transforming requirements to schematics to a first prototype, I think now there's a lot of effort being put there. Like one can hear of different, and now with the boom of AI, right? You have tons of places where you can read AI. I'm developing this. I'm asking ChatGPT or this other AI. Many companies that are starting to implement in electronics the power of AI. We had here a very nice session also in which we talk about how AI influences the process. And there is this with Stuart Gordon, very very nice session that we had. That in the end is the person that has to be behind, right? Many not to criticize competitors, or actually not even competitors, but other actors in the industry that pull like, hey, give me your things, give me your input, and the AI is gonna make it all for you. I think that the human being still needs to be behind. Also, like I don't want to be the engineer that bets my job on the result of an AI. That that I capture everything. Another colleague does the layout. It goes wonderfully through manufacturing, and when the board hits the test bench, things don't work. When questions come, I have to say, "Oh, but the AI told me."
Yeah, but it's a still sort of two sides of the technology. I think if you look at the medical field, for sure,
Yes,
it's just incredible that that how you can collect data and just get more brain power.
absolutely. Although
But I agree.
I would still want to be the doctor, the one that tells me if I have to take ibuprofen or what, right? And so in the end, these are trends that go a lot into capturing the schematics, transforming your technical requirements into some actionable circuitry that you're going to use for your prototype, for example. And my question for you is, what emerging technologies or methodologies in PCB manufacturers do you think designers should be aware of? And how is KSG preparing for these advancements?
So one of the things that has gotten attraction over the last couple of years, but still a long way to go, is additive manufacturing and wafer printed circuit boards. So I think that you just get a 3D printed circuit board and having all functionalities already in there, regardless if this is a long way to go. The challenge earlier is there's no CAD systems handling that. So if you can connect more or less two pads on two layers from here to here. In the past, you need to go through a via, then you go here, another via, then you go through here. Now you can go like this. But how do you design something like that? And so this is for sure something that's going to be something that people need to pay attention to, because if you don't have that, then you can take advantage of all the new technologies.
Yes.
And as mentioned, everything in the printed circuit board might be a little slow in a way that if the assembly process just requires, as of today, temperatures being above 260 degrees C multiple times, and most of the materials that you have in additive manufacturing get problems at these temperatures. So the reliability is something that is not in the way, but is something that needs to consider and slows down the whole process. But for example, what picked up on speed the last couple of years was just putting on the solder mask, the green part that I talked about, with an inkjet on a circuit board. And this idea has been around for 15 years, I think, 16 years. And it sounds so simple, but coming back to the reliability, in a solder mask, there are 20 to 25 ingredients, which just make sure that that you prevent cracks from enhancing and things like that. And these are all ingredients that you typically don't get through a small nozzle of an inkjet. And so this is why this again took more than 15 years to get products that seem to work reasonably.
Yeah.
And so again, but the 3D part, I think something that is chance going forward. If you take advantage of the things that were not able to be done before. And I think we've seen that in the CAD/CAM world, where you have three-dimensional parts out of cast or anything that were not possible to generate in the past, and now it's possible. But you have to have somebody having the brain and the tools to
do that. That's actually a very, very interesting point. I'm, as I said, in a former life, I remember checking this topic, because in the end, if you design in 3D, then you have a lot of freedom, right? You can solve problems in things that you cannot think of right now in 2D on a regular PCB. But then, which tool do you use? If you use an MCAD tool, you don't have DRCs there, right? How do you control the impedance of a couple of tracks that where the dielectric maybe is changing thickness, or right, you're changing the whole geometry of the board, and also when you have to manufacture it, so right, components might have even like different orientations, right? So for a pick and place machine, now it's a bit more complicated.
Yeah, exactly. So basically, it's not just changing one part; it's changing most of the industry. That's
exactly
all around it.
Change a lot, indeed. That is one. We were talking about that like a year ago with some at the, I think it was last Embedded World 2023. How hard it is to innovate in the PCB manufacturing industry, because it's very, very cost driven. And innovation tends to bring the cost up here and there, so it just takes time.
First of all, you need to solve a problem, because
exactly,
if you start up with a technology and you search for a problem, it won't work. You have to have a sort of a roadblock which you can overcome with a new technology, and then people are also more open to go for innovation.
Yes, indeed. It's also interesting. I could be talking about this for hours, but I would prefer to not to make our audience fall asleep, because this can be interesting for me, but and I think it should be interesting for all of you. So don't fall asleep. No, but now seriously, these trends in the end are there or are appearing to solve problems that the industry faces, and these are creative ways to come up with solutions. And one thing that I wanted to ask you is, in this context, this ever pressure that the industry of electronics has of increasing complexity. We're always increasing the complexity, miniaturizing boards. We need less and less power consumption, right? How do you see the role of platforms, as it could be the sales design platform, or modern tools that are arising now in the way this topic evolves, and how manufacturers can collaborate to ensure that these constraints, ever-evolving constraints, are met?
I mean, there's three parts of the question. So the first part is I fully agree that the increasing complexity is difficult or getting more and more difficult to cope with. So I think for that, it's pretty obvious that sooner or later, AI is going to play a main role to recognize patterns and things that belong together and things that don't belong together in a statistical way. But what I see as a challenge, and you mentioned it early on, that for the platform or for the rules, to set up something like that, you need to have enough data points, good and bad, to generate a rule.
Yeah.
And if you squeeze the limits, or if you want to squeeze the limits, then you don't have these data points yet that can be negative. So there's the platforms are good for proven technologies, where you actually have enough market experience and expertise to say, okay, this works, this doesn't work. But if you enter new territories, I think you raise too many expectations. So you have to collaborate and fail fast and then reiterate. And this is something which I don't see working in a platform for sure. It's not sort of impossible, but to give you options and let the people decide what to do. But if you think you get offered a bulletproof solution, that's not going to work. Not for new things. And so I think, as mentioned earlier, to get similar to ChatGPT, if you take past experience, you can enter it into a system. But to derive new things out of it might be misleading here and there.
And how? Let me ask you this: if you had a magic wand, for example, or you find a lamp and there's a genie out of the lamp, what would you ask the genie to improve which type of platform or collaboration with manufacturers would you ask for to improve the process?
That's a tough one. I think what is going to be, I think if you look at platforms, it would be, that's not the genie question, but I think it would make, it would be an option to have sort of vendor customized areas where you have dedicated processing, which if you choose that vendor, then it's going to turn out this way.
Okay.
But because even though a printed circuit board might look similar at the very end, the way to get there can be totally different. And so there are for sure specificas and specialties of each vendor, which get lost if you focus on the biggest overlap. And so, and if there would be a chance to have,
that's a really interesting point.
It would be the option to get the designers to where they want, because it might be a chance that that one of them actually pushes a little further than the other. But if you enter only the overlapping, you might not get as far.
You don't get, of course, you don't get to you cannot differentiate, right? So that's a very good point. I think also note for our colleagues from product to check what Matthias just said, because it would be very interesting to have some type of solution where when you're starting a project, you already have in mind the manufacturing, right? So you might be able to select, what do I tell you? Manufacturer that you want, which might lead you to set of layer stack templates that you can select, right? Or you already have included some DRC rules already that will be transferred when you output your EDA files. That's a very good point, right? Because in the end, connects directly with DFM, which is have the manufacturability in your mind from the very beginning. That's a good wish. That's a good. I would wish that too. Also, from the developing side, I would also wish for that. So I think we are approaching the end of the podcast of this session, in which we talked about design for manufacturing, design for manufacturability, DFM, and I would say if I wanted our audience to keep something in mind, is two things, actually. One, DFM, talk to your manufacturer from the very beginning, always. Two, if that manufacturer is KSG, even better. And check KSG's webinars. As I said at the beginning, I don't know if I've ever learned more about manufacturing and about the things that I need to take into account when they're performing the layout.
Also, we have a special part of the webpage without making too much advertisement, where it's just you have common information about printed circuit boards, about base materials and everything like that.
There you go.
Standards.
There are tons of information, and well, if you want to check it on KSG's website, even better. So I would say, as a closing part, I would thank you, Matthias, for being
having me
here today. and for your insights, sharing them with us. And well, as I said, if you want to explore KSG's website, you are more than welcome. Thanks a lot for sharing your time with us today, Matthias. Thanks a lot to the audience for checking today's session. And I hope to see you soon in the next. Bye-bye.